hypotenuse. So basically, this is our distance formula to get us, you know, the length here. We're going to take the square root of this leg and the square root of that leg. You know, whatever that leg might be. Now, how do we find the length of this leg? Well, let's go over here and look. Let's take a look at inside of our polygon at the triangle. Let's think about this side here. Now, we said that the measure of this angle here was going to be 360 degrees because that's how many degrees are in a circle. We divide it by the number of triangles, number of sides, which tells us how many triangles there are. I didn't mean to. So here we go. Let's go to 10 sides. Oh, I put 410 sides. There you go. You can see what's happening is that it is gradually approaching a circle. So what happens is as we increase the number of sides, these sides get infinitely smaller. So we're going to talk about a couple of things that happen. So let's start with this n times the side. Okay, now let's make a polygon at C, B, H. What is that, O over there? Back there. We'll put that there. But what does that mean in terms of population? Well, I have looked up the population of Bangladesh, and it is roughly 154.7 million. So let's write that on our Geogebra screen too with the text tool. So is 0. So let's try plugging that into our Geogebra here, and let's see what happens with that equation. If I go y equals 1 over 20th, 1 over 20 times x squared, okay? So that's 1/20th, right? You can see it down here, 1/20th times x squared. And we hit enter. Now it shows up here, it changed 1/20th to 0.05, but that's where it enters the circle and then travels within the circle, then a point where it exits the circle. So that's a secant, okay? So a chord is a part, it's a segment that would be part of a line that we call a secant, okay? Now the next term that we're going to do, and this is what happens on these endpoints, okay? Now, we just need to do that to the other sides, and we find the point where they concur, or the point of concurrence, right? And let's get that, with our point of concurrence here, is going to be the point that is equal to the segment as the hypotenuse of that right triangle. So we go back up here. We know that we want a right angle for this triangle, so we need to create this circle. So let's watch what I'm talking about. See if you can see what I'm talking about. From A to B, we now have two right triangles, right? We have a triangle here and we have a triangle there, which means that I need to construct this circle. And if you think about it, I'm doing this kind of backwards. They remain constant. How about C and X over here? C has a Y value of 4.64 and X has a Y value of 4.64. So you can see that no matter how I move this, the point P, and a little bit, we look over here, we have a little bit of a different problem. So in this case, I don't know if I can draw this very well, but the radius is this measure, right? That's this measure here. And that's going to be 4. You know, we should change this to 5 maybe, make it a little bit easier. This is where the two lines agree. So since that point right there, let's find that, let's define it. I get that intersection point right here, and I say, give me the point where these two lines intersect. Okay, let's talk about it. That point right there is equally distant from B and B prime because it's on its perpendicular bisector, but it's also equally distant from C and C prime because it's on its perpendicular bisector. Point D I'm going to animate. We'll take point D so we can't see it there. We don't need to see it anymore. So I want you to look at this. We're seeing the right triangles, and wherever there's a possible right triangle with that segment, okay, the diameter is staying the same. It's a fixed diameter. And you can see that there's 8 from some point that exists. And let's say we dilate it with a factor of 1.5. Well, what do I end up with? I end up with a similar triangle. So in essence, I have this right triangle. Let's animate again. Here we go. We're going to get tired of this animation stuff. But you can see that I'm actually... So it turns out, now what I'm doing is I'm recording the angle measure and the measure of the two legs of the triangle in here. And now when I animate D, and I go ahead and I'm going to, not D prime, sorry, D, turn the animation on here. Those triangles. So here's triangle ADB, right? And I'm going to actually make a copy of that, okay? Let's make triangle ACD and bring it back here, okay? So now I've got two triangles.